Good day, my dear students in Meteorology, Physics 5. How are you today? Our lesson today will still be about the composition of our atmosphere, which we discussed last meeting, but this time we have to identify some physical quantities that operates in the atmosphere, and these physical quantities are indispensable in the study of meteorology. Let me clarify again this physical quantity we call pressure and density. Okay, you see, our atmosphere is composed of air molecules, okay? And they are being held by the force of gravity. Okay? That is why nearer the surface of the earth, there is more pressure and there is higher density. Okay? Now, of course, the force of gravity is invisible. Okay? Invisible, we cannot see oxygen. We do not know what is the color of oxygen air, nitrogen, and other gases. We do not know because they are invisible. They are there around us, but we cannot see them. We can feel them. Their presence we can feel. Okay? But there is that force that pull them toward the surface of the earth. So, there are so much air molecules nearer the surface of the earth because of the pull of gravity. And gases that have smaller density will be above other gases with bigger density. Okay? For a given volume near the surface of the earth, there are more air molecules than for the same given volume farther from the surface of the earth, which has lesser density. Okay? The volume could be the same, but the number of air molecules are different. There are more air molecules near the surface of the earth than farther from the surface of the earth. Since air density is the number of air molecules in a given volume or space, it follows that air density is greatest at the surface, and farther away from the surface, the density of air decreases as we go up, and up into the atmosphere. Okay, now, air density normally decreases, of course, as we go up. That's normal. But if we are going to analyze by kilometers and kilometers farther from and farther from the surface of the earth, the decrease is not uniform. Okay, the decrease is not uniform. Air molecules have weight. If we are going to collect all the air molecules around the planet Earth, oh, they have what we call tremendous amounts of mass, combined mass. Estimated more than 5,000 trillion tons. Estimated. Not less than 5,000 trillion tons. Where 1 ton, if you use the metric ton, is about 1,000 kilograms. Now, this weight of the air molecules is exerting a force on each one of us, on anything on the surface of the earth. And this force per area, okay, if we consider an area in terms of, let's see, square inch, 1 square inch, so 1 square inch, 1 inch by 1 inch, okay, 1 inch by 1 inch, area equals 1 square inch. That's the area. Nearer the surface or at sea level, the force per unit area is about 14.7 pounds in terms of pounds per square inch. Or some books simply call this one PSI, pounds per square inch. And this is about 6.7 kilograms per square inch. I use the square inch because 1 square inch is about this size. 1 square inch is about this size. 1 square inch is about this. So if you have an area 1 square inch, there is this amount of force in terms of kilograms, more than 6 kilograms. 1 square inch of your skin right now being acted on by a force of 14.7 pounds. That's a tremendous amount of force. Now, why is it that we are not uncomfortable? We do not feel that force. Why? Why? Because our body has been biologically adjusted to such force. That is the amount of force. But if you go up, the number of air molecules become smaller, so pressure therefore decreases. And how do we know that pressure decreases? Well, if you go up the mountain higher and higher at higher altitude, you will feel some sound. You can feel like a siren. Of course, very significant when you are in flight. You are inside an airplane. In flight. You will feel pain. Because the first part of your body that will react to change in pressure is your eardrum. Eardrum. Higher pressure, air pressure or atmospheric pressure is smaller because the number of air molecules are lesser. So, external pressure smaller compared to the body pressure bigger. At sea level, atmospheric pressure approximately equal to the body pressure because our body is exerting a force outward. External pressure inward, 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 inward. Body pressure outward. More or less they are in equilibrium. But once you go up, atmospheric becomes smaller, meaning external pressure due to our atmosphere smaller. Body pressure remains the same, does not change. But this time, at higher altitude, your body pressure, which has maintained its value, is now bigger and greater than the external pressure that has decreased. And so your eardrum is being pushed outward by that force, body pressure force. So you feel the pain. And to minimize that pain, you have to remove some of the air from your body. So you are removing, you minimize. Some airplanes provide us something to eat or something to eat just to release some of the excess pressure or pressure that becomes unbalanced now with the external pressure. Of course, my dear students, even if you will not eat something, even if you will not say, later your body will biologically adjust. So later in flight, the pain is gone. So there is now an adjustment. Our body pressure is trying to have some kind of equilibrium with the external pressure. But then when the plane now starts to descend, going down, again, there is now a change in pressure. You will now again feel the pain because your eardrum reacts to the change in pressure. Okay, so there is pressure. Now, so while pressure decreases, air density also decreases. So there is also an increase of the number of molecules in a given space, in a given volume. So in the study of meteorology, we need to know the pressure of the atmosphere. When the pressure of the atmosphere decreases, there is now what we call the low pressure area, which we are going to discuss. That low pressure area is one of the weather systems we are going to discuss. Okay, so air pressure or atmospheric pressure, and the density. Okay, now air pressure, in mechanics, we use this one, or we use Newton per square meter. But in meteorology, we use millibars and Pascal as the units. Where 1 Pascal, the symbol is PA. equals 1 Newton per square meter. Now, in meteorology, we use hectopascal. We use hectopascal. Hectopascal, or in symbols, we have HPA. And remember, hecto is equal to 100. It's a prefix used in the metric system, in the MKS, hectopascal. So therefore, if you have one hectopascal, this is equal to 100 Newton per square meter. 100 Newton per square meter. Okay. So, in other words, our atmospheric pressure is something like 1013.25 hectopascals. This is the standard atmospheric pressure at sea level. Of course, going up the mountain, the atmospheric pressure is less than this. Okay? Now, 1 hectopascal is just equal to 1 millibar. 1 hectopascal equals 1 millibar. Okay? Or this is equal to, in terms of the height of Mercury, 29.92 inches of mercury. So these are conversions. Don't worry, because during your exam, you can open your notes, of course. So I'm just giving you the values, standard values. When the atmospheric pressure is less than this one, there is what we call a low pressure area. So in meteorology, we always look at the atmospheric pressure. Of course, higher than this, you have a high pressure area. High pressure area, the weather is good. Low pressure area, the weather is not good. It will be a rainy day for places where there is the LPA. For the high pressure area, it will be a sunny day for places where there is the HPA, high pressure area. Okay, so take note on this one. So you should know how to convert this one in terms of Newton per square meter. You have the conversions there, so don't worry. You have the conversions. So what is this one equal to in newtons per square meter? Okay. Now, so the higher we go, the lower is the atmospheric pressure, and the smaller is the air density. Okay? Then, you have there the what we call layers of the atmosphere. So, you should familiarize what is a troposphere, what is a stratosphere. You have, remember I gave you the reading material. It's an ebook. What is a mesosphere? What is a thermosphere? Okay? And what is the boundary? What do you call that boundary between the troposphere and the stratosphere? What do you call that boundary? And what does that boundary imply? Okay. Then, with these layers, okay, you will know that for every kilometer, there is the amount of decrease in the air pressure, and there is the amount of decrease in air density. You have that in your ebook, which I sent to you. And also, not only the pressure that we should know in meteorology, not only the density, but also the temperature. Because the temperature also decreases with height. Estimated for every, not estimated, as the result or one of the results of the study, that for every 1,000 meters, there is an average change in the temperature of about 6.5 degrees Celsius. Meaning to say, going up for every 1,000 meters or for every 1 kilometer, because 1,000 meters equals 1 kilometer, there is an average, or there is a decrease of about 6.5 degrees Celsius. Meaning, as you go up, it is colder and colder. And at a certain height, the temperature there is negative 90 degrees Celsius. You know, when you are going to touch the surface of your freezer, open the refrigerator, there is the compartment of the freezer, you touch the surface, the temperature there is between -4 and -10 degrees Celsius. And you imagine -90 degrees. Okay. Why is it that it's as you go up, it is colder? Why colder? Because near the surface of the earth, the surrounding air is being warmed. It's being given the warmness of the earth. Remember, our earth absorbs heat coming from the sun. And when it absorbs heat, it radiates some amount of heat. There is warming. Moving away from the earth's surface means moving away from the warmth of the earth. Farther and farther, you are far from the heat given off by the planet Earth by means of the reflected heat coming from the sun. But then, as you go up farther and farther, you must know how many kilometers away from the earth there is the start of the warming. it will be warmer than when you are near, when the air molecules are near the Earth. Remember, from the surface of the Earth, okay, from the surface of the Earth, you have here the Earth, you have here the Earth, so all the air molecules here are being heated by the solid Earth. And where does the Earth get the heat? Coming from the sun. Because some amount of heat coming from the sun will be absorbed, will be radiated, will be reflected in all directions. And the air near the surface will be heated by the radiated heat coming from the solid Earth. And of course, including the oceans. Because the ocean waters also radiate heat. And you can feel that during nighttime. You live in a coastal barangay, during nighttime, it's warm. That is because the ocean water or the sea water radiates heat. So further, this air will become colder because it is now further from the source of heat coming from them. Further and further, very cold. I told you negative 90 degrees Celsius. And beyond that, however, you cannot expect to have more than negative 90 degrees because beyond that, the air will become warmer. Why warmer? Why warmer? Because here there is that layer that absorbs the heat, some amount of the heat coming from the sun. And that heat coming from the sun will be radiated to the surrounding air. Now, which layer of the atmosphere? The mesosphere, the thermosphere, you have that in the ebook I sent to you. Now, what is the difference between elapsed rate, okay, and the temperature inversion? What's the difference between the two? Lapse rate and temperature inversion. Well, I will just answer that question. In a lapse rate, the temperature of the atmosphere experiences a decrease. And I mentioned to you, for every 1,000 meters, about 6.5 degrees Celsius, the amount of decrease. For temperature inversion, it's the reverse. The atmospheric temperature now increases. So, lapse rate, temperature inversion, they are opposite to each other. And what is the significance of this one? You have to read that in the ebook I sent to you. Okay. So, you have the mesosphere, then you have, well, next to the mesosphere, what is next? Okay? What is next? What is that hot layer above the mesosphere? What is that hot layer above the mesosphere? I will answer my question. We call that the thermosphere. Okay. what is that thermosphere? What happens when light coming from the sun passes through this layer of the atmosphere? What happens? Ladies and gentlemen, the oxygen molecules absorbs that highly energetic solar radiation. And what happens then? What happens? What is then the result of absorbing the energetic solar radiation by the oxygen molecules in the layer we call the thermosphere? What happens? Okay? So there, well explained. Well explained by the ebook there. And there is that illustration. And you have the graph there. Okay? What happens from the troposphere to the stratosphere, then to the mesosphere, then to the thermosphere, and to the exosphere. So you have a lot of spheres, but there is another sphere we call the ionosphere. What is that ionosphere? Ionosphere, by the way, the ionosphere is not really a layer. It is not classified or categorized as a layer. It is just rather a region of electrically charged material within that upper atmosphere. Ionized. You remember your chemistry. You remember your charges in electromagnetism. What are these ions? What is an ion in your electromagnetism? I will answer my question. An ion is a charged particle. If you have an atom where electrons are lost, or an atom where there are losses of electrons, that atom becomes a positive ion. Because there are now less number of negative particles than positive particles. Remember that when an electron is removed, the proton, which is a positively charged particle, will now dominate the charge of the atom. The atom now becomes a positive ion. And if there are more electrons absorbed by the atom, that atom becomes a negative ion. Okay? And these ions, we can find them in the ionosphere. What is the role of this ionosphere in communications? What's the role? I will answer my question. The significant role of the ionosphere can be observed using your transistor. your AM transistor. What's the difference between AM and FM stations? AM station, FM station. What's the difference? Well, the difference, one among others, is the wavelength. The FM station releases shorter electromagnetic waves compared to the AM station. Let us have the AM station. During daytime, there is a region in the ionosphere we call the D, letter D region, because we have letter D region, E region, and the F region. Now, this letter D region, somehow, during daytime, is very aggressive, very energetic in preventing the radio waves to go farther, because the farther the radio wave will go, the longer the distance it will cover when it will be reflected. Because these radio waves will be reflected. During daytime, it cannot go further, higher, because the D region of the ionosphere will block that wave so that the radio wave will be reflected in a shorter distance. And what is the effect? Shorter distance, you can hear less number of radio stations during daytime. But during nighttime, you have so many radio stations that you can hear. You can even hear Chinese-speaking radio stations. As far as Taiwan, as far as mainland China, Hainan, you can hear there Chinese-speaking broadcasters, because the radio waves have traveled higher, and therefore when it is reflected, it will be reflected to places farther. So that is one of the rules of the ionosphere, and there are still many rules there in meteorology. Okay. Now, let us have a brief review. Atmospheric pressure at any level represents the total mass of air above that level. And the atmospheric pressure always decreases with increasing height above the surface. Always, the atmospheric pressure always decreases with respect to height, with respect to altitude. The higher the altitude is, the smaller is the atmospheric pressure. And the atmosphere may be divided or could be divided into layers. So I told you what are these layers. And you can see that further in the ebook. What are these layers? And one of the layers there, the mesosphere and the thermosphere, will contribute to the warming of the earth. Why? Illustrated also in the ebook. And I told you also that oxygen molecules absorb the energetic solar radiation. And when it absorbs, it radiates, warming the atmosphere. Then we have that, you have that layer, okay? In the stratosphere, you have that ingredient. You have that region in the stratosphere we call the ozone region. And what is the role of the ozone region? And when is ozone beneficial to mankind, and when is ozone harmful to mankind. Explain also in the ebook I sent to you. Okay, now let's go further. In our course, Meteorology, we always talk about weather. When we talk about weather, we are talking about physical conditions of the atmosphere at any particular time and place. Of course, weather is always changing. There is no weather that has not changed. Weather is always changing. There is always weather change. Why? Because our weather is comprised or is constituted with indispensable elements. And what are these elements comprising the weather? Number one, air temperature. And you know what is temperature? As simple as the hotness or coldness of the air. Air temperature. Then you have another physical quantity, air pressure. I explained to you, air pressure, force per unit area. So you have the air pressure. Air exerts pressure because it has force due to its weight. Then you have also what we call humidity, which is the measure of the amount of water vapor in the air. How humid the air is. We are referring to the amount of water vapor a particular amount of air in a given space is carrying. That is humidity. So, another element of weather, clouds. Clouds, they are just water vapor actually visible. Because these, the clouds we see above are actually very small, very tiny water droplets or ice crystals over there, above there. Why clouds are white? Why clouds are white? I will answer my question. Clouds are white because all the wavelengths of light are reflected toward you, toward me. And we see no color except the appearance of white. Of course, in our study of satellite imageries later, you have dark clouds, you have lighter clouds. Why dark clouds? Why lighter clouds? Why? I will answer my question. Dark clouds, gray clouds, because these particular clouds carry so much water. Nimbus clouds are gray clouds. Nimbus clouds are carrying so much water, and that clouds will start to precipitate. There will be precipitation. Later, the heavier, the greater will be the precipitation. The darker, the more water to be dropped. Okay, lighter clouds, less water it carries. We will be discussing more on that. So, when we speak of weather, we are talking of those elements. Air temperature, air pressure, humidity, clouds, then another precipitation. We are not referring to rainwater. Not only rain, sometimes solid snow that falls from the clouds and reaches the ground. Precipitation. So that is part of the element of weather. And these elements keep on changing and changing and changing from time to time because they are dynamic. And these elements are energized by the heat of the sun. In here, you have also what we call visibility. So in weather, we talk about one of its elements, visibility. During rainy days, visibility is poor visibility. Poor visibility. That's why expert pilots will not just land on the airport with poor visibility. How poor is poor visibility? Well, I just give you a good visibility during daytime. During daytime, you can see as far as 30 kilometers of jeep. Assuming that, for example, from Dumaguete, you look at Cebu Island, you can see some objects there represent, which are buildings. That's good visibility. Secure Island, you can see some structures there. That is true. That happens on a clear daytime. Good visibility, you can see objects as far as 30 kilometers. Of course, it depends on the size of the object and the color of the object. Okay? Then another element in weather condition is wind. We talk about wind also. So these are what we call the weather elements. These are what we call the weather elements. And, okay, these weather elements keep on changing. And when we are going to consider all these elements for a longer period of time, let's say, for several months, we are going to measure them, monitor them for a longer time over a specified interval of time for many years. Then we would obtain what we call the average weather. That's the average weather. And when we say average weather for 5 years, what is the average weather for 5 years? Considering those elements, what is the average weather? We call that average weather as the climate. The climate. We study all those elements in a particular region. Let's say Negros Oriental. Let us say Cagayan de Oro. Let us say Cotabato, Davao, Metro Manila, Samar, Bohol, Cebu, the average weather for 5 years. We are studying the climates. Climate, therefore, represents the accumulation of daily and seasonal weather events. The average range of weather over a long periods of time, by years. But of course, the concept of climate is much more than this. For climate includes extremes. The extremes of weather. The extreme heat, extreme cold, part of the climate. Heat waves of summer and the cold spells of winter that occur in particular region. And the frequency of these extremes is helping us to distinguish among climates that have similar averages. So that is how. And then, in summary, the Earth and its atmosphere are dynamic systems that are always changing. So, climate change, such has been with us. Climate change, such has been with us. Not worrying. What is worrying is the global warming. The global warming has changed the occurrences of ferocious weather systems. That even a low pressure area is already alarming. During my childhood days, low pressure areas are not worrying to us. What we worry are typhoons. Because typhoons carrying strong winds and more rains. But of course, casualties do not usually happen because of strong winds, because of typhoons. Casualties happen because of floodings. Even if there are no typhoons, no storms, but because of low pressure areas, there are always floodings. Of course, there are many factors. One factor, less number of forests, less number of trees. But even if all areas are covered with trees, even our house is covered with trees, but because of global warming, the amount of water that will be dropped will be so much. Why so much? Because our planet Earth is becoming hotter. Hotter. So more water evaporated. More water going up. And what goes up comes down. Because of the law of gravity. More water going up. more amount of water going up because of rising temperature due to global warming, more water will be dropped. Even if there are no typhoons, just an ordinary low pressure area, that is already fearful to us, especially if we are located at the foot of the mountain, near riverbanks, at the foot of the mountain. When there are more rains dropping, more water dropping, the ground will be softened and landslides are possible. Near river banks, overflowing of water